and welcome to Scale Factors, Diagrams and Maps with Cubit Education. So in this mini lecture you're going to understand a scale and what it means, so what it's telling you. You're going to produce a scale drawing of your own, or at least watch me do it so that you know how to do it and have a go, and then use a scale to read a map. So let's have a look at some scale drawings. So scale drawings can be seen everywhere. So here we have a map, which is our best idea of a scale drawing really, because a map is a much smaller version of very, very, very large roads. So we must use a scale in order to make it smaller, but still so that we know exactly where we're going and in what time. The blueprint of a house is also a really good one to look at because, again, it's a smaller version, but still in proportion to everything else based on the actual size of the house. We also have a scale drawing here of some fish and vehicles, or a tank. So, the scale drawing allows us to draw large objects on a smaller scale while keeping them accurate. All scale drawings must have a scale written on them, and scales are usually expressed as ratios. So for example, 1 centimetre to 100 centimetres. Now that means that every centimetre on the scale or on the map or on the picture or diagram is actually 100 centimetres in real life. Okay? Now sometimes it might just say 1 to 100, it might not give you the units, but then usually in your GCSE exam, if that happens, just use your ruler to measure it and assume that it's in centimetres. So the ratio of 1 centimetre to 100 centimetres means that for every 1 centimetre on the scale drawing, the length will be 100 centimetres in real life. So a scale of 1 centimetre equals 2 metres, then, must mean that for every 1 centimetre measured on the drawing represents 2 metres in real life. So let's see why we need to know how to use these. Here is a map of a town. The scale on the map is 1 centimetre represents 200 metres. Which place is exactly northeast of the park? Circle your answer. Now obviously this isn't necessarily about scale, but I figured this would be a good time to just quickly recap north, south, east and west. So as we can see, it says which place is exactly northeast from the park. Here is the park, and here is our compass. Here is north, and here is east. So this one right in the middle here must be northeast. So if northeast is in that direction, we can go to the park and we can see that the station is northeast of the park. Okay, so now let's find somewhere we have to use the scale. So question 1b, I'm not going to look at that one. I'm going to miss it out because we've not done bearings yet and I don't want to confuse you. So we're going to look at question 1c, which is 3 marks. What is the distance in metres from the mall to the station? Well, the mall to the station is there, and we need to measure that line. So we can see there that it's 8 centimetres. Now on our scale it says that 1 centimetre represents 200 metres. Well, that means if 1 centimetre is 200 metres, 2 centimetres would be 400 metres, and so on. So I just need to times this by 200 to give me 1600 metres. And that is my answer. Okay, let's have a look at this question then. So here is a map of an island with cities A, B and C, and the straight lines represent the roads. Now, I'm just going to skip this question here because it was something to do with bearings. So I'm just going to do this 5 marker just here. And it says that the scale is 1 centimetre represents 200 kilometres. Joe drives from A to B on the route shown. Ash drives from A to C to B on the route shown. Use the map to work out how much further Ash drives than Joe, and you must show your working. So we first of all need to work out the different lengths. So if we work out the length A to C first, we can see that that's 4 centimetres. Okay, then if we measure the other line, we can see that C to B is 3 centimetres and A to B is 6 centimetres. Okay, so I know all the lengths now. So what I'm going to do now is turn those into kilometres by timesing them by 200, because 1 centimetre represents 200 kilometres. So then also 3 times 200 is 600 and 6 times 200 is 1200. Okay, now we must be careful here because the actual question says that Joe drives from A to B. Okay, so all I'm going to do is find out now the different routes that they took and see who drove the furthest. Okay, I've added them all up here. I can't remember why I did that, so we might need to use that in a bit. So Joe drives from A to B, okay, so we can find out Joe. So Joe was 1200 kilometres. A to B or B to A was 1200 kilometres. Ash drives from A to C to B. Okay, so A to C is 4 and C to B is 3. So altogether, that's both of those added up, giving us a total of 1400 kilometres. It says, how much further did Ash drive than Joe? Okay, so we can just take those away from each other. 1400, take away 1200 gives us 200. So 200 kilometres. So we didn't actually need to add all of these up, but if you needed it, it was there. And it was 5 marks for that. Okay, so well done if you got that one right. Okay, so why don't you pause the video and have a little go at some of these questions. They're a little bit different, but the same kind of concept. Okay, if you pause the video, it says that the diagram shows a man and a tree. The man is of average height. The man and the tree are drawn to the same scale. Write down an estimate for the real height in metres of the man. Well, a man could probably be between 1.5 and 2 metres. So you can just estimate that and how you would do that. In real life, you could look at a person and think, how tall is the average man? Okay, so if you're really struggling with that question in your exam, and it does come up quite often, you know, try and remember this answer if you're not sure. So 1.5 to 2 metres is the real height of the man, but it says to find an estimate for the real height of the tree, and that's because we can take the size of the man, and it looks like that man is probably about, or that tree is about 3 times the height of the man. So we can just do so I took the middle number, anything between 1.5 and 2. They do expect an actual answer, so just put in the middle 1.8. And then because we kind of estimated that the tree was 3 times the height of the man, we can times that by 3, giving us 5.4. Okay, so we can also use scale drawings to kind of find lengths of smaller objects, like a television, for example. So this scale drawing has a TV that measures 4 centimetres by 2 centimetres, and the scale of the drawing is 1 centimetre equals 25 centimetres. So what is the actual width and height of the TV? Because obviously we can't watch a TV that's only 4 centimetres long, or wide, because it would just be too small. So what we would do then is we need to just times everything by 25, because we have 4 centimetres, not 1. So I need 4 lots of 25, giving me 100 centimetres. And then 2 times 25, giving me 50 centimetres. Okay, and you've found out the lengths of the sides. Okay, so I just want to go through an example of drawing, like a scale drawing, on a grid like this. So you might get this in your exam, and it might say draw the house on the squared paper. So here it's telling you that 2 small squares is 1 centimetre. So this is 5 metres, this is 9 metres, and sorry, that's supposed to be 10 metres there. Okay, so I know that if that's 10 metres, okay, I'm going to use a scale of one of these centimetres is 1 metre. So if one of these is a metre, then I need 10 of these larger squares, so 20 small squares. So I've just counted along here and done 20 small squares. Okay. Then I know that this is 9 metres, so I'm going to do 9 larger squares going up the side. And then we can just square that off. Okay, so we've got 9 large squares there and 10 large squares along here. Okay. Finally, this 5 metres here, we can just measure 5 centimetres going up and then just draw our sides going down and label it. Now the only thing that I haven't done here, which you should, is just to show, like write down 1 centimetre equals 1 metre, because you will have to give it a scale unless it already has done so for you. Okay. Okay, so why don't you pause the video and have a go at this question. Using a scale of 1 centimetre to 9 metres, pause the video and try drawing the accurate version of this triangle. Okay, if you pause the video and had a go, or even if you didn't and you've got some paper available now, sorry about my mistake here, I will explain to you how you can draw this in a smaller, because you wouldn't be able to fit a triangle that was 45 metres on your page. So we have to think, okay, well, 1 centimetre is 9 metres. Okay, so if I wanted to turn this side into centimetres, I'll just divide by 9. 27 divided by 9 is 3. Okay, so 3 centimetres. 36 divided by 9 is 4, and 45 divided by 9 is 5. So then you could fit an accurate drawing of that triangle on your paper and write down that this is the scale that you used. Okay? Okay, so I have a quick map task here. You have 2 questions. Number 1, how far is the Olympic Stadium from the Aquatic Centre? So this is a map, of the Olympic Village. And so you need to find how far the Olympic Stadium is from the Aquatic Centre, and how far do you have to walk from Stratford International Station to the Copper Box for the handball event. Okay, so if you haven't noticed, there is a scale just here. Okay, so it's telling me that that length there is 200 metres. Alright, now here's the Olympic Stadium, so let's go for question 1. Olympic Stadium, and there is the Aquatic Centre, and there is our journey. Now, in these questions, if they have not given you numbers, and you are using a scale like this, it's okay to estimate a little bit. But if they're giving you actual numbers, so an actual length for this, then you would use the multiplication rule that we've just been using. Okay, so this is our scale, and I'm just going to use this estimate to see how many of those fit there, and I can fit about 2. So for number 1, it must be 400 metres, because one of those is 200 metres, and it's about 2. Okay, so 400 metres. Number 2, how far from Stratford International, which is there, to the Copper Box? Okay, and again, I'm just going to estimate how many I can fit. About 4, probably a little bit more. You probably 4.5 maybe. Again, in the exam, they will give you kind of a leeway. So if you get in the middle of there somewhere, you'll get the right answer. So don't panic. It doesn't have to be dead on if they're telling you to estimate. Okay? So our answer for this one must be 800, because it's one of these is 200 each. So 2, 4, 6, 800 metres. Okay? Okay, so in this lecture then, I'm hoping now that you understand a scale and what it means, what it's telling you to do. You have produced a scale drawing, whether you tried to do the house or the triangle. If you didn't have a go, please go back and try. I'm sure you'll be able to do that now. And you know how to use a scale to read a map. So well done. Thank you so much for using Cubit Education, and I'll see you next time.